In this example, I want to verify this identity. So remember, with identities, we always want to start on one side and prove it equals the other. And since this side is a lot more complicated, we're going to start on the left-hand side and prove it equals the right-hand side. But before I start, what I want to do is I kind of always make myself a note. This is what I want. I want secant theta. And just to remember, what is secant theta equal to? 1 over the cosine of theta. That is where I'm going. So what I do is I start with the left-hand side and we just write it out. So I have 1 plus cosecant theta over cotangent theta plus cosine theta. So how are we going to start this problem? This is what I want, and on this side I have three separate trig functions. So I think the best thing to do with this, nothing squared, maybe a Pythagorean identity might not help at this stage. So let's just write everything in terms of sines and cosines. So I have 1 plus cosecant theta is 1 over sine theta, all divided by cotangent theta, remember, is cosine theta over sine theta, plus cosine theta. So I've got a complex fraction. Looks like a big mess. So the best thing to do is to figure out what the LCD is and get rid of my complex fraction. Go to my first denominator. I need a sine theta. Go to my next denominator here. I need a sine theta. I've already got one. I don't need any more. So remember, my other denominators of my other terms are just 1. So what I'm going to do now is I'm going to multiply this term, this term, this term, and this term by my LCD of sine theta over 1. Whoops, that didn't come out. So it's sine theta over 1. I'm going to multiply each term by sine theta over 1 because I'm really multiplying by sine theta over sine theta. So remember, what you do to the numerator, you do to the denominator. So does anything nice happen? Well, if you notice with this term, the sine theta is reduced. Just leave me with 1. This sine theta in this term will reduce with this one. So what do I have left? My first term is sine theta plus 1 times 1 over 1 times 1 is 1 over cosine theta over 1, which is just cosine theta, plus cosine theta sine theta over 1, which is just cosine theta sine theta. Okay, so look where I'm going. This is all I want. Okay, what do I have? Well, if you notice, the numerator cannot be simplified, but how about the denominator? I can factor out a cosine theta. So if I factor out a cosine theta out of my two terms in my denominator, cosine theta factored out of cosine theta gives me 1. Plus, if I factor cosine theta out of this term, it's just going to leave me with sine theta. Now, does this expression equal this expression? Yes, 1 plus sine theta is a factor of the denominator, so I can reduce it to this with the sine theta plus 1 in the numerator. Because remember, 1 plus sine theta is equal to sine theta plus 1. Addition is commutative. Now what has it left me with in the numerator? Don't forget, when I reduce this out of there, I get 1 over cosine theta. Is that what I wanted? Yes, so 1 over cosine theta equals secant theta. So I've now proved that the left-hand side equals the right-hand side, and I'm done.